All right. Thank you for joining me today. I'm Mason Kresge, a Senior Applications Engineer at Oxipital AI. Today I'm going to walk you through our recipe builder and show you how Oxipital AI is truly changing the game on how AI is applied to the machine vision space. All right, let's get started. When setting up an inspection system with a traditional machine vision, the first step you would need to take is identifying instances of the product to be inspected. This would be done with pattern match, edge, and blob tools. You can adjust these thresholds and pixel values, and eventually you'll be identifying instances of the product and can tell the system what to look for on each product. With the VX2, the product detection is pre-trained out of the box, and there's no need to set up any identification tools, and instead you can start with defining the filter criteria about the products you are inspecting. Let me show you how easy it is to set up one of these recipes. Here is our recipe builder. Okay, so what you can see on the screen now is our recipe management and our recipe builders. We have this screen just so that you can change for various products or for customers. You know, sometimes customers of Walmart would have more stringent filter criteria than someone like a Sam's Club, right? So each recipe will be a bit different. If I go into edit, I'm able to change just the name, make it whatever's human readable or whatever your operators use, as well as put a description just so people know what you're working with. For the camera, this is typically something you're going to do once and done. For this one, what you'll see is we can increase this area here to say what are we actually looking at. You want to make sure that you include the belt, but sometimes you'll limit this based on the robot's pick area or if you only see a portion of that belt. For the tooling configuration tab, we're able to choose any tool we want. We are pretty tool agnostic. We have predefined parameters for suction, as well as soft gripping through M-grip from Schmaltz. All of this is configurable, and if there's a non-traditional tool that we have in here, you can ask us to add whatever you need. We're not going to need the controller tab today. We're not doing any picking, but if you had suction or soft gripping, this would essentially tune the suction power, as well as the ability to how much you would put pressure onto the fingers, as well as open them. Detection. Like I mentioned before, we have pre-trained object models. With this, you're able to select the model. In this case, it's just the corn dog model. But if we had other instances such as pizza, corn, any other product you can think of that we've trained a model for, you would just be able to select that here. And the tracker, this is usually a once and done setup. When you have some products on the conveyor belt, what we'll do is we'll make sure that you tune it in so that you get proper counts. We don't want to double count the same product if it's actually the same product. So we're just doing all tracking things here. And the filters are where things get really interesting. We've heard a lot of feedback in the field that it's really hard to actually set these recipes up. So what we did is we made this very human readable, no program, and it's very easy to understand. So before I start showing you the filters, I actually want to show you what we're looking at. All right, if you notice, there are some not so good looking corn dogs here. You wouldn't be too happy to receive some of these. As much as I love corn dogs, something like this big corn dog, we can filter out real easily. For each corn dog, I can actually see the overall length, width, and some other key parameters on this one. So you can see this long corn dog, he's sitting around 230 millimeters long. Compared to the 150s, yeah, it seems like about 150 is the normal length of these corn dogs. So what I'm going to do is I'm going to go back to the recipe management screen, hit edit, and I'm going to go straight to filters. For this, we saw that the big corn dog, it's over 150, it's about 200. Just to give us some margin, I'm just going to call this about 160, 170. And let's scroll down. We'll save and exit just so that the recipe changes, and then we'll reload. From here, we go back to our pick view slide. Okay, let's take an image. And you can see we've removed the big corn dog, but we still have a few problematic points here. The easiest one to identify for me is this tall corn dog. He's laying on top of two other products, and what that'll likely mean is that they're baked together or the two products would be underbaked. So if you go and click on a product, you're able to see just general dimensional information, and for this one I'm specifically looking at height. These products should be laying down on the belt, so with this one having a height of around 60 millimeters, and the neighboring products being around 20s to 30s, I'm just going to put a filter in, let's say around 40 millimeters. So going back to the recipe management and then edit, we'll go back to filters and scroll down to position. In this case, there aren't many things that cover shape, but in general, you could, if you had like crackers, a rectangular form factor, you could do minimum rectangularity, or for circular patties, something like circularity. But in this case, I'm going to do a maximum height above the floor. Right now, this is at 29, so we'd actually be filtering out some good products from the default. So I'm just going to increase this to, let's just say 45, and let's see what happens. Scroll down to save and exit, and reload. Again, we're just going to restart the cell. It's going to take some time for the changes to come into effect. Then I go back to pick view. All right, and now that the image is refreshed, you're able to see that this tall corn dog has been removed. Everything else is still here, and for those who have been looking at the screen, you can identify some very clear, easy defects. We have some broken sticks here, here, and here. We have a product that's entirely missing its stick, and we also have two products that are missing breading. We wouldn't want to send these to the customers, but since the model is pre-trained, we're able to turn on classification. You can see where the model is doing well, or if there needs to be some sort of parameter changes. All right, looking at these, it looks like broken sticks and missing sticks are performing really well. So let's just remove those. We don't want to have to package those. We're just going to let them ride off the conveyor belt into the trash bin. So from here, I'm going to go back to recipe management, edit, and filters. We scroll down, we're able to go by category, inspection rules, and in this case, I am going to remove the broken stick. I'm just going to do one by one just so it's easy to see how the scene changes here. And then same thing, we reload. All right, now that the scene's refreshed, you're able to see that we have all of the broken sticks removed, but we still haven't addressed the missing stick. So let's go back and filter that guy out. So we're going to go back to recipes and edit, down to filters, scroll down. It's just as simple as selecting missing stick here. So we will save and exit and reload this. Same process every time. I usually recommend doing this one by one just to make sure you're not changing too much at one time, because sometimes things are on the edge and you might miss things. Back to pick view. And we wait for this image to refresh. Okay, now that we've refreshed this page, what you can see is all of the defective ones with broken stick and missing stick are missing. But you can see we're correctly labeling this one as displaced breading, but we are not labeling this one. Typically, we'll do some light tuning before we send you a recipe, but in this case, we might have missed it, we might have made it too aggressive, and you can also address this seasonally. So something like a plant, right, like corn, you're able to change seasonal variation, right? So in the spring, you might have beautiful plants. The summer, maybe it was a bad harvest, and we need to change the criteria of what is good, what is bad. Maybe it's grade A, grade B, grade C. So in this case, I'm going to just figure out why we need to change the parameter. Okay, so in this case, you can see where my cursor is. We've labeled the broken breading area about 300 millimeters. And when we look at the one we're missing, it looks like we're filtering out because we have a broken breading area of like 100, 130. If we have a really strict customer, we might lower this to an extreme value. So I'm going to put it at something reasonable. Going back to recipes, I hit edit, scroll down to inspection rules. Here you're able to change all of the inspection rules. It seems like we got broken stick and missing stick calibrated pretty well. Let's just make this display spreading a little more aggressive. So rather than filtering an area, it needs to be over 250. I'm going to make it identify any area over 50 millimeters to be called display spreading. So save and exit, and once again, reload. Okay. Again, it's just going to take a little bit for this to come back up, and we'll see if our tuning fixed it. Okay, we're back up with it now, and you can see that we've correctly identified both pieces of display spreading as display spreading. Now that I'm confident that we're identifying all of these, let's go back and make it so that we don't pick these, right? We want to make sure we're only packaging good product because all of the other product's going to run off the conveyor belt and get put directly into trash. So I'm going to travel back to recipe and edit. Back to filters. Scroll down and let's remove all instances of display spreading. Save and exit and reload. And back to pick view. All right. So now that we've filtered out all of the bad product, let's figure out the best priority to pick these, because we can do some sort of balancing here to make sure that we're having a good rate. So if I do overlays and go to pick priority, we'll now number these. And just to make it easy to read, let's remove the bounding box as well as the center point, which will make it really easy to see. So right now it looks like we're going farthest downstream. So we've identified this is the first pick, this is the second pick, and this one is the third pick. In certain circumstances, picking the center pit product might actually be the fastest because that's the most optimal location for the robot. So you'll actually squeeze out just a few more products per minute. So let's focus on that real quick. Go back to recipes and edit. This time we're going to go to sort. We're going to just enable proximity to center. And just like that, we will save and exit and reload. Go back to pick view. And it's just going to take some time for this to come back up. Okay. Now you can see with just a simple click of that box, we now have changed the sortation of this. It's really that simple. You can change it for things like a pile picking. You might pick the highest product and work your way down from that pile. But in this case, it's really simple. We just chose the center one, which you can see it is correctly identified. For other circumstances, maybe we want to pick number 3 as the first one, so the farthest upstream. Once again, we'll just go back to recipe, hit edit, go to sortation. We'll disable this filter here and do distance downstream. In this case, let's invert it. So we actually want to do the farthest upstream. And save and exit. And reload that recipe. We'll then go back to pick view. Okay. Now that we've taken a new image, we've reevaluated the scene, and you can see the ordering has now gone in reverse from that initial scene, going from farthest to the right to farthest to the left, going 3, 2, and 1. So now we are picking the farthest upstream product. All right, just to recap, the recipe builder is easy to use, no coding is required, and there's no need for any software engineers or any sort of programming skills. The intuitive filters give any user the control to select and adjust the product's quality requirements and even pick priorities when using a robotic picking solution. A key thing that makes Oxipital AI different from the other vision companies is that we provide our customers with a pre-trained vision model of their product. This eliminates the need for our customers to have machine learning resources as well as the time burden required to build and train a vision model. There is no need for pattern match, edge, and blob tools. You're ready to go out of the box to identify the product and the associated defects. All right, I'm going to hop off for a few minutes just to review the questions that came in.
In the meantime, if you could just answer the question, the last poll, that'd be greatly appreciated. Thank you. All right, looks like some questions came in. So for those of you who answered no, I'm glad you guys are feeling comfortable, but just in case, our model library doesn't cover exactly what you guys need, for you guys, I'd wonder if there's any specific products you want to see how we go about building the recipe or even the model. And for everyone who's kind of got lingering concerns, I'd want to know what you guys are concerned about. I'd love to answer some of those questions in our Q&A. Okay, so let's take a look. This looks like a great question. Who determines, the defects such as display spreading? It's actually kind of a team effort. We kind of use Q&A documents and real life products to give you the pre-trained model. You don't need like a vision expert to come in, tweak the blob tools or edge detection parameters to get the right amount of breading. We'll bake that in so there's no code needed. You don't need any sort of expert to do that. Can I see the overall results of picks and defects? Actually, yes, you can. We call this the analytics dashboard. Even without any sort of automation, you're able to make actionable insights to improve efficiency or reduce waste. An easy example would kind of be something like baking cookies. You can watch live how well those cookies are being baked, if they're underbaked or overbaked, and then you can change conveyance speed at when you need to make it bake for more or less time. We actually did a webinar on this recently. You can check that out on our YouTube channel. Okay. How many images do I need to get a model? You actually need no images to get started. Instead, we ask for a few good products, a few bad products. I'm thinking about 5 or 10 of that each class. We'll handle the rest for you so you can just get in and edit those parameters like I did today. If you guys think of anything else, feel free to shoot me a message. Just to remind everyone, hope you enjoyed the recipe builder demonstration today. I'm Mason Kresge. My contact information is on the screen. Feel free to reach out with any questions, comments, or concerns. I love any feedback you could provide for me. To learn more about Oxipital AI, please visit our website at occipitalalai.com. From there, you can use our Contact Us form to request a demo, talk to a sales representative, or even do some sort of proof of concept testing. All right. Thank you again for joining us today. Hope to see you next time. Have a good one.